In Experiment 5, we're going to use the power of absorption and fluorescence to determine the concentration of quinine in tonic water. Here, we have the electromagnetic spectrum. As you may know, as the wavelength increases, energy decreases, and vice versa. For this lab, we will focus on the ultraviolet and visible light spectrum. On the left, you see lightning bugs. Lightning bugs emit light or fluoresce due to their natural fluorescent protein known as luciferin. To the right, you see the Jablonski diagram. This diagram is a representation of the electronic states of an excited molecule and the transitions from excitation to emission. Let me talk you through the Jablonski diagram. You have electrons in the ground state, naturally, that are then excited by an excitation source going from the ground state to the excited singlet state, here S2. Then, through vibrational relaxation, to the lowest level of the S2 excited state. Then it will go through internal conversion from the S2 to the S1. Again, vibrational relaxation to the lowest level of the excited S1 state. Then it'll emit its energy via non-radiative or radiative emission. Non-radiative is generally giving the energy off as heat, or radiative could be fluorescence. It will give off light and be fluorescent. If it doesn't fluoresce, it could go from the excited S1 phase to the excited triplet phase. This is known as intersystem crossing. Again, vibrational relaxation to the lowest level of the excited triplet state, and then give off light or emit, known as phosphorescence. You may have seen this before with glow-in-the-dark toys, and those are phosphorescing. Different fluorescent dyes and fluorescent proteins can be utilized to probe different structures to help further study physical attributes of biological systems. You can see in this figure a eukaryotic cell fluorescing different colors to differentiate between the nucleus, tubulin, and actin. This is one small example. Fluorescent molecules can be applied as a tool in the research world. We will use a UV vis to determine your sample excitation wavelength before using the fluorimeter. A UV vis works by a source sending photons through a monochromator, source here, monochromator here, to single out a specific wavelength to send through your sample. This will be your incident light. The more concentrated your sample is, the more the particles in your sample will absorb the incident light, which causes a decrease in light to reach the detector, which then will be transmitted light. The instrument calculates the difference in transmitted light to incident light and displays a spectrum relative to the wavelengths absorbed by your sample. You will then use a fluorimeter to determine the fluorescence spectrum of your sample. A fluorimeter uses a reference beam to measure the ratio of fluorescence emission intensity to excitation intensity. Why is the emission filter and detector at a 90-degree angle from the source? Well, the fluorescence instruments are designed this way to detect photons emitted from the sample without the photon pollution or noise from the source. This is commonly known as increasing the signal-to-noise ratio. Quinine. In the 19th century, quinine was used as a prophylactic drug against malaria. Today, it is used to relieve leg cramps and mixed with delicious popular adult beverages. In the literature, it says that the tonic water contains up to 83 ppm quinine. In the lab this week, you will determine the amount of quinine in tonic water by making a standard curve using UV vis and a fluorimeter. Please pause the video and take notes on this slide. Please pause the video and take notes on this slide as well. Please pause the video and take notes on this slide too. Please pause the video and take notes on this slide. This slide talks about your post-lab report. Please make sure in your report that you have a fluorescence spectrum, so just graph your wavelength versus intensity, and provide your R-squared value, provide your y equals mx plus b formula, and use your y equals mx plus b to develop a concentration curve from your standards. Okay, you all have fun in lab this week.